Hi dear students, so today let us study the new topic, properties of addition of rational numbers. Okay, so in the last classes we were dealing about the rational numbers, how to add them, right? And what are the properties and how to represent a given rational number on a number line. These were the things which we were discussing in our last classes. And today we are going to study about some of the main important properties. Actually, why we are studying this property, because we are going to apply these properties when we are going to solve the given problems. When a problem is given in front of you, you must know some of the properties so that very fast you can deal with them. For example, just imagine a big door, okay? There is a big door. Just imagine the door of your home itself. You know that there is a keyhole there, and just imagine that you have to there is a key given to you and you just want to twist the key. After inserting the key into the keyhole, you just twist the key towards the right hand side, automatically the door will be open. So unless and until you know that what is the use of this key, you are having the key in your hand but you don't know how to use it, where to insert this key, in which hole we should put this one, you have no idea. If that is the case, then how you are going to open the door? Definitely that door is not going to be opened in front of you. But whoever knows that this is the property behind this one, this is the criteria which we have to do, or this is the method which we have to apply or implement, very fast you will get into the solution. So these properties which we are discussing in today's class is having that much significant. That means it plays an important role. If you know these properties, definitely when you are seeing or when you're dealing with a problem, it will come into your mind that you have to solve that in such a way. So as to give the solution in a greater method and easier method, we are going to study some of the properties. So let us go with the first property, the closure property. The closure property. The closure property of addition of rational numbers states that the sum of two rational numbers is always another rational number. If you're adding two rational numbers, just imagine a by b plus c by d, two rational numbers. If you're adding two rational numbers, the solution will be also another rational number. Means one rational number plus another rational number is going to give a result of another rational. It will be definitely another rational number only. Okay, so that is the first property. Going to the second property, the commutative property. The commutative property states that the rational numbers can be added in any order. That means if you're taking a rational number a by b, another rational number c by d. Okay, if you're adding a by b plus c by d, that will be equal to c by d plus a by b. That means 1 by 2 plus 3 by 4 will be also equal to 3 by 4 plus 1 by 2. Means you can change the order. It doesn't matter that you must, it's not like this that you have to take 1 by 2 in the first portion, then you have to write the second rational. It doesn't matter. Wherever you are keeping the order, if you're changing the order, that makes no sense. Actually, if you can change the order, that means you can change the order for your convenience. That's the meaning. If you're changing the order also, there is no problem. The value of that thing is not going to change. So this property is what we call commutative. Means you can add any two rational numbers in any of the order. In whatever order it is given, you can simply change the order for your convenience and you can add them together. Is that clear? Going to the next property, the associative property. So in the first two cases, I told a by b and c by d, means there were at least two rational numbers, right? Dealing with two rational numbers, we told the first two property. Coming to the third property, the associative property, we must take at least three. At least we are going to start with taking three rational numbers. So if you're taking any three rational numbers, as we mentioned right now about the commutative property, same thing, you can change the order. That means if there are three rational numbers, okay, a by b, c by d and e by f. First of all, you can group them together. A by b and c by d, you can group them together, add a by b and c by d together, then find the solution of that one. Thereafter, by using the solution, add it with e by f. It's okay. Or another one, keep that a by b there itself. Okay, keep there itself. Just group the next two rational numbers together. That means c by d and e by f. Group them together, find that solution, and after getting the solution of this one, add it with a by b. It's okay. Also, we can say take the first rational number and take the last rational number, add them together, then you will get an answer. And from that one, you can add the center term also, add the middle term also. That means you can change the order by grouping them. In whatever method you want, you can group them together. What is convenient for you? By looking the denominators, you can feel something convenient. For example, in the last class, we discussed how to add two rational numbers if they're having the same denominator. So, if in this case, just imagine that there are three rational numbers given for you, and the first rational number and the third rational number, both of them are having the same denominator. So, what you can do? You can add the first one and the last one very fast, right? If it is 1 by 2 and another one is 7 by 2, you can simply add 1 by 2 and 7 by 2. The 1 plus 7 is 8 by 2. Very fast you will get the answer. Then this one can be added to the second term because already there are 3 terms. So when you're dealing with plenty terms, I just told about 3 terms, but it can be more than 3. At least it should be 3. Okay, that's the meaning of this one. So if you are adding them together by using any group, by making them to suppressing them to any group, it doesn't matter, you will get the same answer. Actually, why we are grouping this one, there may be a question into getting into some of the students that why should we group them? Is it mandatory that we should group? No, it's not like that. Don't think that we have to group it. We must group. If there are 3 rational numbers, we have to group it, then only we have to add with it. It doesn't matter that whether you're grouping or not, you have to get the solution. But when you're grouping them together, actually you will get the answer in a easier method and very fast also. Okay, you can consume your time. Time management is very important when you are appearing the examination hall, right? So when you are appearing into the exam, definitely time is something which is considered very highly. So that's why I tell you, these properties, why we are studying means to apply these things when you are doing the exercises, so that you will get the solution of the given problem in an easier method, in a faster way. So actually, don't think that it is a mandatory that we have to group them. It's not like that. Just seeing the denominators. If the denominators are familiar for you, if the denominators are same, or if you can find the LCM of the so-called 2 denominators very fast, then definitely group them together. Okay, even if you are not grouping also, you will get the answer. Even if you are not grouping, just as I told in the previous section, I told you that you have to find the LCM, and then by using this LCM, you can find the answer. No problem, you can do like that also. So, which is easier? That's what you have to choose. For example, just imagine that you have to cut your nails. Okay, you have to cut your nails. A scissor is given for you, a knife is given for you, and then one nail cutter is given, one screwdriver is given. So there are plenty of tools in front of you. Your question is, you have to cut the nails. Which instrument will you use? Or which is the thing which you are going to choose? Will you choose a knife? Knife is a thing which is used to cut, right? Scissor is also a thing which is used to cut, but not nails. But actually, let me ask you, can't you cut your nail by your knife? Definitely we can. If there is no other way, then we can take a knife and we can simply cut your nails. It's okay. But the relevant one is, the original one is the nail cutter. It is provided for you. So use that one for easier outcome. For getting the result in an easier way, you have to choose the correct thing. So there are different methods to add the rational numbers, to subtract the rational. There are different methods, but you have to choose which is the relevant one, which is the important one, which is the easier one. That's why I told you, you can group or you can just keep it as it is, and simply you can find the LCM also. But using the associative property, the associative property says that you can group them in any order. It doesn't make any change to the given solution, but it will give the answer in a easier method. So the associative property says that while adding the rational numbers, we can group them in any order. The next one is what we call additive identity. There are multiplicative identities also there. Additive identity, that is very important. What is the meaning of additive identity? The meaning of additive identity is that if you are given a rational number, you have to say that by which rational number should this one be added so that you will get the same rational number as the answer. That means A by B is given. You have to add, because it is additive, that's why I am using the word add. If it is multiplicative, I will use the word multiply. Okay. So by which number should A by B be added so that the result will become A by B only? That means the result should be the same as of the question. Then What is that number? That typical number is what we call the additive identity. Actually, the additive identity is 0 itself, because any rational number, if you're adding it to 0, it will be the same rational, means a by b plus 0 will be also equal to a by b itself. So that is what we call additive identity. If it is multiplicative, it's not 0, because if you're multiplying by any number by 0, it will become 0. No, we should get the same number. So if 3 by 4, it's a rational number. If you're multiplying that with a particular number, if you're getting the same 3 by 4, that typical number which you multiplied 3 by 4 is what we called the multiplicative identity. So that is 1, right? Because 3 by 4 into 1 will be equal to 3 by 4. That's why there's a huge difference. Multiplicative identity is 1, but additive identity is 0. Okay, so additive identity is what we call 0. So 0 is regarded as the additive identity. Clear? Next one, additive inverse. Additive inverse. From the term inverse, you can see that it is something opposite, right? Inverse means up down something, means changing the order of something. It makes sense like that. So what is the additive inverse? The additive inverse of a by b is minus a by b, means if it is a by b, the additive inverse will be minus a by b. So if I'm asking you what is the additive inverse of minus a by b, it will be plus a by b. That means the additive inverse of minus 2 by 3 is plus 2 by 3, and the additive inverse of minus 5 by 7 is plus 5 by 7, means just change the sign. Change the sign. That is what we call the additive inverse. Additive inverse. The additive inverse of 3 by 4 is minus 3 by 4, and the additive inverse of minus 5 by 4 is plus 5 by 4. So additive inverse means changing the sign. That's all. Why we are using this additive inverse, I will tell in the next topic. Now we are getting into that topic. How to subtract two rational numbers. Subtraction of two rational numbers. As we studied in the last class about addition of two rational numbers, same thing we are going to apply here. The same method, that means the second case. I told you in the last class that the second case, that means taking the LCM, that is the standard case, and we will use that one only in our future classes also. So there we were using plus sign in between because it was addition. So here what we have to do, just use the minus sign or just use the negative sign. But actually I told you this additive inverse we are going to apply in this subtraction also. That is the more easier way. For example, a by b minus c by d. Okay, a by b minus c by d. So you have to subtract a by b and c by d. There are two different rational numbers given. So instead of subtracting the second rational number from the first rational number, what we will do means we will add, because addition is more important, more easier than subtraction, right? For me it is like that, because whenever I used to subtract, I used to get a little bit confused whether it is right or wrong. Again, I will have to think for a while when I was a student. So that's why at the time I used to think like this. If it was addition, it was very easy. So similarly here, rather than subtracting if a rational number from another rational number, we are going to add. So how can we add? We simply, it's not like this that simply just wipe out that negative sign and just put their plus sign and add them together, you will get that. It's not like that. Something is there. Just listen this one. A by b minus c by d. Instead of subtracting c by d, you have to add the additive inverse of the second term. What is the second term? It is c by d, right? It is c by d. What is the additive inverse of c by d? It is minus c by d. So instead of subtracting a by b minus c by d, we are going to write like this: a by b plus minus of c by d. Means change the sign of the second term and then add them together. That means in simple words we will say a by b plus additive inverse of c by d. So second term, whenever you are adding, whenever you want to subtract two terms, change the sign of the second term and then add it with the first term instead of subtracting. So this is how we are going to implement, or we are going to use the properties of rational numbers while solving the given problems. It will be very easier for you. In the next class we will deal with some question and answers, and there we are going to implement all these things which we have learned in today's class, so that it will be very easy for you. So that's it for today. So meet you in the next class. Till then, take care and goodbye.